You know what's truly incredible? Our universe is filled with galaxies, swarming with wildest tales of cosmic history, explosive genesis, elusive forces, and challenges so deep that they may redefine everything we once believed. Let me take a closer look at how these mysterious entities come to life, what they're hiding, and a revelation so massive that you'll be dumbfounded by it. Stay tuned. Promise this is going to leave you speechless. So, what are galaxies really about? Galaxies are super cool and big groups of stars, gas, dust, and extra stuff in space that need to be mixed up and taken care of by gravity to work the way they do. They are the fundamental building blocks and main components of our universe. From tiny dwarven galaxies with just a handful of stars, to really big, massive ones with countless stars. Galaxies can look different, and they can even have all sorts of shapes and sizes. Plus, their role in figuring out our universe's origins and how it's changing and growing is super important and crucial. Now, we all know the universe is a pretty huge and complicated place with loads of amazing things and secrets waiting to be figured out. One of the coolest and most intriguing mysteries is about galaxies themselves. While galaxies has been around for a bunch of years, we really only start getting to know them and learn from them in the past few decades. And it's only been in the past few years that studying galaxies has really took off and allowed us to get a much better and deep grasp of this fascinating cosmic thing. Galaxies do a lot more than just look like cool clouds in space. They are the foundation of our universe and are super diverse and plentiful. From little groups with a couple of stars to huge spaces with lots of galaxy clusters. Studying galaxies can help us get a better understanding of where we fit in the universe and what kind of role galaxies play in the huge space between stars. Figuring out galaxies is super important in our quest to learn more about the mysteries of our universe's birth and how it's still changing and evolving. By studying these complicated celestial structures, we can learn even more about the secrets and intricacies of dark matter, dark energy, and all the different forces that make up and put together the fabric of our universe. As we keep on digging deeper and exploring the vast expanses of space, we're bound to find even more hidden secrets and contribute to our growing understanding of the incredible universe's wide array of mysteries. The galaxy classification. Galaxies are divided into three main types, depending on their distinct looks and sizes, by renowned astronomer Edwin Hubble. Around the early 20th century, this format helps us get a deeper look at the various properties and behaviors of these amazing celestial objects. The three types of galaxies are: 1. Elliptical galaxies. These galaxies have a round or a little bit oval shape and are known for their centralized gathering of light and mass. They tend to be more luminous and less lightweight than spiral galaxies. 2. Spiral galaxies. These galaxies have a curved outline or arms and consist of a central bulge and a spiral of stars and gas. They tend to be more massive and less luminous than elliptical galaxies. 3. Heterogeneous galaxies. These galaxies have a complicated internal structure, featuring multiple elements, like an elliptical or a disk galaxy core, and a bridge or wing of star-loving material connecting two or more galaxies. They tend to be less massive and more luminous than spiral galaxies. Spiral galaxies. Appearance. These celestial bodies are characterized by a flat, rapidly rotating disk that exhibits a central bulge and spiraling arms, extending outward in various directions. The arms appear to be prominent, showing bright elements such as young stars, scattered gas clouds, and fine dust particles. Examples. Some well-known examples of spiraling galaxies include the Andromeda Galaxy M31, situated in the Leo constellation, and the Milky Way, our own galaxy, prevalent in the Virgo constellation. These giants are noteworthy for their striking appearance and the presence of prominent arms. Features. Spiral galaxies are primarily identified as active star-forming regions, characterized by their arms containing a substantial concentration of gas and dust. Approximately 60% of galaxies present in our local universe are classified as spirals, displaying a wide array of shapes and sizes. Discussion. Spiral galaxies are known for having an important role in the formation and evolution process of the universe. As they evolve, they generate strong gravitational forces, leading to the formation of new stars and planets. These galaxies often show signs of interaction or merger events, which altered their physical attributes over time. Elliptical galaxies. You might see them look a bit all-round and clean, without any distinct features. But trust us, these awesome stars are actually close enough to be called spheres, or maybe even medium-sized eggs. They're really captivating and mind-blowing, too. They don't have the typical arms from spaghettis we get in most galaxies. Now, there are tons of amazing galaxies we know of, like M87. That's a super famous black hole picture we found out in 2019. Another cool example is the Andromeda Galaxy, this huge group of stars in a constellation called Andromeda is always one of the most gorgeous and inspiring things in the night sky. Ellipses usually look like older, lighter stars and don't have a lot of stuff or cool gas. That makes it tough for them to make new stars like other galaxies do. You can see them in all sorts of sizes, from super tiny dwarfs to huge ellipses, which are pretty much 70% of all galaxies we find in the big, wide universe. Irregular galaxies. Hey, galactic enthusiasts. Let's talk about those peculiar galaxies we often encounter. Although not always typical, they still shine brightly in their own special ways. So, let's dive into some examples. The Large and Small Magellanic Clouds are actually more of an irregular galaxy than anything else. You can usually spot them in the southern hemisphere. If you take a moment to look up at the night sky, and speaking of star-obedy galaxies, there are loads of them out there too. In reality, irregulars make up roughly 10% of all galaxies in our vast universe. It's like a galaxy extravaganza. So, when you take a peek at the night sky, keep an eye out for those peculiar galaxies that make up the cosmic realm. Who knows, you might even catch a glimpse of a brand new constellation. So, galaxies are more than just stars, right? In fact, they're made up of several different parts that are pretty intricate. Stars, you can usually spot these cosmic bodies up above, from young, bright blue stars to older, cool red ones. These changing stars can affect a galaxy's life cycle in a few ways through their evolution: gas and dust. This essential stuff is what usually sparks star formation. There's a whole bunch of nebulae, like the famous Orion Nebula, that are made up of gas clouds and can be found in galaxies. Dark matter. We don't see this mysterious stuff directly, but it's vital to hold galaxies together. Many believe it makes up about 80 to 90% of a galaxy's mass. black holes, just a few galaxies, like our own Milky Way, have supermassive black holes at their core. These mysterious spiders can do cool things, like draw in more solid stuff or shoot out major amounts of energy. It's important to know that galaxies are made of a bunch of parts, coming together to create something truly amazing and awe-inspiring in the great expanse of the observable universe. Alright, so let me tell you how the universe came to be, and it all started around 13.8 billion years ago. During the Big Bang, this is what I like to call a basic, straightforward explanation: starry poppets. So about 13.8 billion years ago, there was this Big Bang happened, and that opened up the universe. Everything that was there before then started swirling together and got bigger. Then, some of the stuff started drifting apart and formed the first stars, forming stardust. As the cosmic stuff kept mixing up and forming more stars, it started growing even bigger. Big stars, those really massive things that we see in the sky, were able to do this because their insides were getting hotter and hotter as they got bigger. Star making, as the huge stars kept on getting bigger and formed different shapes, they started making their planets too. So you see, these first planets were born after all this, and the universe is kind of like our neighborhood now. Cosmic tapestries, the universe kept being formed and changed as a result of this whole star thing. We know eventually our own Milky Way galaxy will go head to head with another galaxy called Andromeda in about 4.5 billion years, and there will be a huge cosmic battle there. Ever-encrusted galaxies keep getting bigger and changing as a result of stars forming like never before. The whole circle of change makes the universe expand still more. We are just starting to see some of the great things our universe has to offer, and I think it's cool that we're just scratching the surface of what it can do. Who knows what other secrets and amazing stories we're gonna find out soon. Just keep looking, but don't lose yourself in all of the beauty our universe has to offer. The Milky Way, our groovy galactic fellow. Type, a barred spiral galaxy. Measurement, a good bit over 100,000 light years in diameter. Stars, it's said to have between 100 to 400 billion within it. Position, we find ourselves in the Orion Arm, about 27,000 light years from the heart zone, with a powerful, massive black hole called Sagittarius A burying itself. Visibility, it has a barred center, a blend of stars, and spiraling arms extending out in each direction. These arms encompass a mix of stars, gas, and dust, helping create our very universe. Formation, the Milky Way galaxy got its start from a blend of smaller galaxies that collided. The array of features and varied details we see today were shaped due to the consistent movement and interaction of these separate clusters of stars and gas elements. Origin process, the Milky Way galaxy was born from the colliding of a bunch of smaller galaxies. The perplexing structure and unique features shown today came about because of the continuous movement and interaction of these various groups of stars and gas particles. So there are a bunch of galaxies all over the place, right? Yeah, that's right. So, according to everything we know through Hubble and the James Webb Space Telescope, there are around 2 trillion galaxies out there in the universe. Wow, that sounds like a lot. It really is. The size of the universe is about 93 billion light years, and these galaxies are all spread out all over it. So, how do they group up together like that? Well, Galaxies like to hang out in clusters. We call them groups, and they can be part of even bigger groups, like the local group, which has our own Milky Way galaxy and Andromeda galaxy in it. What are some cool things about galaxies? Well, sometimes we can see galaxies that are way older than anything we thought the universe could have made. That's right, some of them look like they were created around 300 million years after the Big Bang. And what about the way galaxies move around? When galaxies are moving through space, they can sometimes crash into each other. But thanks to the vast distances, the stars don't usually get hurt. Instead, they can create pretty amazing structures like tidal tails or rings. Now, we don't always know why we study galaxies, but I'm sure you could guess that they're interesting because they give us clues about the universe's history, what it's like today, and what might happen in the future. Yup, that's right. Galaxies can really help us learn about everything from the beginning of time to where we might go next. If you thought this adventure was cool, give it a thumbs up, share it with your buddies, and subscribe for more space-themed stuff. Catch you later. Keep gazing up.